with no further ado, let me hand over the mic to JJ. You got it. Over to Jim. And what's your name, Jim? Go ahead.
And I'm Jim Rondinelli. I'm the president at Immersion Networks. We are a Redmond, Washington-based audio lab that is focused on solving difficult problems. Our work is entirely based around the work of my distinguished colleague, J.J. Johnston, who I'm proud to be able to introduce to you tonight. Small plug. If you have an audio problem that seems unsolvable and it's in your infrastructure or your supply chain, we are the people you call. You can always get my contact information from anybody here at the meetup. I also have cards here. But I'm delighted to introduce James J.J. Johnston, Carnegie Mellon graduate, ex-Bell Labs, but better known as the inventor of the AAC codec, a contributor to the MP3 codec, and the creator of the color tables in JPEG. So without further ado, let me turn it over to the star tonight, J.J. Johnston.
Well, it's the alternate color tables in JPEG. We seem to be having a slight video issue. Yes. Okay. What was that? Okay. And Fiat, now I get it. I'll get it. Fiat Lux. Okay. I'm gonna go up to the top. I'm gonna go through a bunch of stuff at a very high level tonight. The question is how do you do immersive audio? How do you make sure you can still hear things that you must hear when you're doing immersive audio? How do you make little squeaky feedback sounds? But I'm going to create some, I'm going to give you some terms here. Immersion means that can you turn the treble down on me a little? Thank you. What immersion means is you get the sensation you're in a different space, in the space that you want to present, not the space in the room, for instance. Although you can be a little tricky, we could actually make this sound like a big concert hall. I'm not sure we could make it sound like a teeny tiny studio, but I'm sure we could make this sound like a really nice concert hall. And then there's envelopment. That's the thing where it's around you. You can hear things to the side, you can hear things to the back. You hear reverberation and room tone and stuff like that coming from the appropriate directions, not just coming from the front. And then another term, SPL. This is very old. Everybody knows what SPL is. SPL is also mostly harmless. But SPL, for many years, was the way to try to measure how loud something was, how loud it feels. And since the 1960s, especially, people have worked on loudness. I mean, this goes all the way back to Helmholtz and Fletcher, so it goes back to the 1890s. But loudness is the perceived signal strength. And when you're working in audio, that's your guy. That's what you want to listen to. Because I can tell you, if I put in, an 80 dB tone at 20 hertz, it won't mask anything. If I put in an 80 dB pink noise starting at maybe 200 hertz, you won't have a clue what I'm talking about. So the spectrum of the audio matters, and the loudness varies massively both with frequency and with the bandwidth of a signal. So loudness is the thing you want to work with. And articulation is very simple. Can you understand it? There are actually very complicated ways to measure articulation, but the answer is don't mask the formants of the speech. It all comes down to that. If you can make out the formants in the speech, you can understand what somebody's saying. So we work on articulation and dialogue protection, things like that. Having said that, first, loudness. Well, loud is bad for articulation for a number of reasons. Your ear has a filter bank, When you get above about 70, 75, or 80 dB, the filters get wider because you're overloading the mechanism. As they get wider, that makes it harder to make out the speech because the ear is actually unable to analyze the signal as well. I put a reference in later that you can pick up if you want to learn a whole lot more about this. And loud is, of course, bad for you. I mean, you only get one set of inner hair cells. When you blow them out, you don't hear much. Okay. As far as articulation, well, articulation runs from maybe 200 to 7 kilohertz. There is voice energy well below 200 in some people, but the information comes from about 200 to 7K. The difference, the difference you hear the telephone band is 200 to 3200 or 200 to 3400. The 200 is fine, but if you want to tell the difference between you need something more than just the 32 or 3400 kilohertz. 32 or 3400 hertz, obviously, not kilohertz. And it doesn't mean articulated things that have been processed for articulation do not necessarily sound natural. If you really, 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 really need to understand it, there is processing you can do that will make the voice sound quite weird, but you will get the message. Now, some places this is good, some places this obviously would be bad. So what we try to do when we work is usually try to make things that make the articulation good, but don't sound like little space monkeys or something. Later, we'll actually have a demo of that. Now, production issues. Well, if you have, say, a channel or you have a dialogue track or something like that, you need to protect that. Now, this makes mixing hard sometimes. If you have a big boom, what do you do? If you have, say, a lot of Venezuelas going off in the back of the stadium, what do you do? If you have a lot of crowd noise, what do you do? And it is possible to actually deal with all of this if you figure out what the noise is, what the masking properties of the noise are. Masking means it covers up the other audio, and then you process the things you want to protect, which is almost always dialogue, in a way that they still have the same partial loudness being a function of frequency, as they had when you had no interference, which means you push them up above the masking threshold by an amount that I can explain in about 45 minutes. This means that really using loudness is the way to go. You use masking thresholds and loudness. You do not use SPL, you do not use energy. They will both mislead you a lot of the time. Energy is better than nothing, yes, I will agree with that. But what you really need is something which has frequency shaping in order to get the best natural sound. And this is a bunch of stuff for learning about masking and loudness. I understand they're going to be putting the deck up, and that would be a good idea. The basic idea, though, is that loudness is a function of both level in each one of the filtering bands in the ear and of the bandwidth of the signal, because loudness in two different bands adds quite differently than loudness in one. You know, if you double the loudness, double the energy in one band, the loudness goes up by about, somewhere around 1.3 times the factor. If you double the loudness, if you double the energy by putting all that energy in another band that's widely separated, it will double the loudness. In order to double the loudness by just letting the gain, you're going to have to put in almost a gain of 10 dB. So how loudness relates to SPL is not convenient. It's much better to just use a loudness model to start with. And basically, the thing to remember is that loudness is a function of spectrum. It really is. And at very high frequencies or very low frequencies, a high SPL may not yet be audible, so it has a loudness of 0. And for those of us who are 70, anything over about 14K has a loudness of 0, but that's a different problem. So now Jim is going to do a demonstration. This is just a monophonic demonstration. You want the mic?
Thanks. Generic Bluetooth speaker. And I'm playing something, this is one of our latest developments. So in recent research, CBS published to the public a statistic that shocked all of us when we read it. 34% of people watching television in the United States at any time watch it with closed captions on, taking up 50% of the real estate on the screen. All those hours that we put in to editing and color correction and sets and lighting and everything lost to a ticker that shows asynchronous captions of the dialogue. And why? Oh, by the way, and 21% of Americans use closed captioning part of the time. Combined total 55%. Why? Language. Language diction, but there are problems. Audio balance is a problem. A lot of people mixing in film theaters and it not translating. But there are simple solutions for all of this. We've developed something that we're going to show you now that's very simple. This is our project for dialogue enhancement, articulation enhancement. This can live anywhere. It can live at the back of the remote truck. It can live anywhere in the supply chain. It can even be an app that lives inside the player app itself. We have an SDK for that. And what we do is very simple. We try to make it very simple to the users. We fix the problem by putting the control of the relationship between dialogue and program in the hands of the customer, because they're the people who are complaining about it, and they're the people, they're the people who we're serving. There are two schools of thought about this. People who are responsible for engagement at networks love it. You, every once in a while, get somebody in the remote truck that says, that wasn't the artistic intent of my mix. At which point we point out to them, what is being broadcast on the air is also not the your artistic intent, because there are so many points of failure from when it comes out of your nonlinear editing system to when it goes to the customer. So we correct that. I'm running the app on my phone. I'm going to just put the microphone down here, should be close enough, so everybody can hear. This is a demonstration that we did using content that was made available to us from a large overseas broadcaster. You can probably guess who it is when you hear the language. And I'm going to be toggling before and after. And the interesting thing about this remote ENG piece, where the reporter is actually like standing on the side of a highway. So you can imagine, with an omnidirectional mic, so you can imagine about how well that worked. And here's what we ended up with. If it plays.
Football. Campbell and Yorenda, hello to you in Zambia, says, and Sheila, the porridge made from maize meal. And earlier in the week, we heard how the eclipse united people in Ghana, thanks to Charles Montpier. Today on the phone from Bangalore in India is Melanie Kumar. Hi, Melanie.
Hi. Hi.
Can I ask you, do you live in Bangalore?
Oh, yes.
And do you have a family?
Yes, I do. A husband and a daughter.
Okay. So tell me, what is your experience of a disunited India?
Let me play some more of that. as I'm toggling back and forth, I'm kind of intentionally not identifying when I'm toggling it back and forth, hoping that you'll be able to hear a clear difference.
Presence of someone who passed away, you can go where they are and ask for help from them. We believe it is very bad to steal them, defile them. If you do that, a bad omen will follow you.
This week we're asking who or what unites the people of your country. We've had a range of answers. Pius Ngoa in Cameroon, along with lots of you, says football. Campbell in Urenda, hello to you in Zambia, says Nshima, the porridge made from maize.
She sounds like a wind filter, windsock is in front of her without the noise cancellation. There's less intelligibility. I hear less intelligibility from the base sample that you're sharing.
It sounds like she is in a fight with lawn equipment and she's losing.
And that was before she got hit by the truck. So that's just an example of one of the things that we've used this technology for, kind of one of the real world problems. Other problems that we are solving for people include a fix for the circle of hell, what we call the circle of hell of 1770. 1770 is a loudness standard that was adopted by the industry because there was a legislative outreach that identified this as a big problem people were even calling their Congress people about. So the industry gets together and says, we need a standard, and then somebody said, but it has to be free. And we ended up with 1770. The problem with 1770 is you can break it with 2 sine waves. It's not very good, and if you listen to broadcast outputs now, you know that it doesn't work. So that's another one of the things that we've resolved that we have available for streaming services and others. But the really interesting stuff is the work that JJ and our colleague Paul Hubert started about 9 years ago, delivering 3-dimensional next generation sound experiences over a pair of standard stereo headphones, where an output of this is one audio production process makes every output that you need. Mono, 5.1, 7.1, 7.1.4, any reasonably definable output with symmetrical speakers, we can accommodate. So with that, back to JJ.
Thank you. What is the goal? The goal is to be able to actually produce this stuff once and use it. And the other goal is to actually put in good actual ways to do stereo imaging or multi-channel imaging, adapting to the hearing. Our whole process looks at the perception, not at the least mean squares or the energy level, because that will really badly mislead you sometimes. So what do you do when you try to make something, say it can be, let's take 7.0.4. You'll notice I never talk about subwoofers. We'll get to that in a minute. But if you're trying to make something in 7.0.4, in the current setups, you have to basically point things in different places. That's all fine. You mix it into all these speakers. But generally, that's done without any direct diffuse control or any automatic directed diffuse control. You can't really make the distance stand out. And the other problem is that you have this issue of stereo image tearing because you don't have any time delay in the system. And the time delay is variable with direction, so that's how you actually make it work. People said, oh, it's just pan pods. No, it's not just pan pods. Pan pods will not work for this. It's not, and people say, oh, it sounds like you just add reverberation. Well, we certainly add diffusion, sometimes reverberation. That depends on what you're simulating. For instance, if we have completely dry recordings, we can put you in a big live room, or we can put you in a big steel pipe that rattles like mad. We can we can put you wherever you want it. I mean, we're sort of trying to encourage some of the gaming people to pick this up too. It's like some of the middleware they use now, except rather a much higher quality audio. And and this is the real key for all this. You have to match what the ear actually can detect. We do not try to model the acoustic space. We try to model the actual auditory cues that you can hear in the acoustic space. If you try to figure out, just try to, even using the mic or not, if you tried to reproduce the sound field around your head, you could do that with maybe 6,000 to 8,000 channels. It's not very practical, but if you're going to put sound in the plane, you can do it with 7. If you're going to put sound with the plane with elevation, you can actually do it with 9, and you can do it very well with a 7.4 system. Again, I'm not talking about subwoofers, but the key is you have to provide the right perceptual cues, and that's the real trick to making the whole thing work. It's the same issue as loudness. When you adapt to loudness, that's great. If you try doing the articulation enhancement you heard here with signal to noise ratio, it will jerk the level of the background up and down and all over the place, and that's just not what it should sound like. Now, right now, you wind up making a mix for 7.1 or 7.0 or 5.0, and you make a mix for Atmos, and you make a mix for stereo. And you have to do all of these. You probably use different reverb. You don't use the same depth cues that you're accidentally putting in. If you're doing stereo and you're not using the time delays for positions, you only really have 3 valued positions in a stereo signal, which is all the way left, center, and all the way right. And how many people here know what the glockenspiel problem is? Okay, the glockenspiel problem is if you record a glockenspiel mono and you play it anywhere except left, center, or right, the attack will come in the center because of the time content, because that sharp attack, your ears will pick that up as located in the center because the time cue will dominate. But then when the ring starts, it will be over wherever the HRTF cue is. So you hear the thing, you hear the image moving around, and if you get exactly at 1/4 or 3/4, it's really, it's kind of fun to listen to, but it doesn't sound much like a glockenspiel. And what you can do instead is you can use proper time cues, and now everything is in the same place. When you do that, you'll actually also make yourself more able to hear depth cues. One of the things that was proven in 1933 was that having only 2 center channels, actually messes up the dead center distance cues because it puts a filter, because the paths from the 2 speakers to your ear, each ear, puts a bit of a filter in to the monophonic signal that steps on the near field depth cues. Now, when you do stuff with the proper time delay and adding some dispersion, that doesn't happen. But you should really have 3 front channels. What about side channels? Well, if you want to have any good envelopment, you can do some imaging with back channels to side channels, although it's not as simple as it sounds at all. You can do some by working really hard, but to have good side-to-side imaging, you really need side-to-side envelopment as well as imaging. You really need 2 side speakers. And just the same, you need 2 back speakers. So that 7-channel thing means you have 3 fronts, 2 sides, and 2 backs. The reason for that is that your ear and your brain automatically can compare the direct sound with the reverberant sound in a room. And if you listen from the side, that's going straight down your ear canal, that's pre-emphasized pretty heavily. If you're listening from the back, all the high frequencies of about 6K are just chopped off by your pinna. But if you put the same signal into both of these, that's going to give you the same reverberation in the room, and now you're automatically going to compare the reverberant signal in the room you're listening in with the signal that reached you initially, and that will mess up things like front-back masking. It can do a lot of things wrong. So having 7 channels is the way to tile the plane as far as the perception is concerned. And then when you go to up, you need either 1 or 2. Depends on if you're not going to actually pan things up, you can get away with 1 channel which is run with something running at the decoder that provides proper dispersion for it. If you're going to image stuff up there, then you need 4 channels. So that's basically what it comes down to. 7.4 is sort of the minimum. And pretty much there you can put things almost anywhere. So yeah, I was going to get somewhere in a minute. But the point here is that what we can do is we can take 1 mix with the interface you'll see, and you can tell the renderer to make it stereo or 5-channel or 7-channel or 7.4, or if you have something like a theater that happens to have, 2 back speakers and 4 side speakers, you can, as long as you can describe it basically with R, theta, and phi to each of the speakers, and they're reasonably symmetric. If you have a complete lack of symmetry, well, that's your fault. But if you have a reasonable symmetry, you can make pretty much anything that you want out of it. We can add up. We can actually do down, but very, very rarely do you actually hear through the floor, so we don't usually deal with that. And we also control very tightly the direct to reverberant ratio from the speaker so that you can get both closer and farther away. So you actually get a good distance cue. And that may seem funny, but you can. It's very easy to make a small room sound big. But if you do it carefully, you can actually make a big room sound reasonably smaller, and that's because the sound from the speakers will get to your ear before the reverberation in the room. And if you have enough of the ambience of the desired venue as opposed to the one you're playing back in, you can get a decent sense of the environment that you want it to be. And of course, if you play this back in a really dead room, you can just get fantastic results. And that, frankly, is how they should build theaters, but they don't. So, having said that, we will skip to what Jim is going to do. I think you're going to put up the interface first and show them, and then we're going to steal a person from the audience, because here we can only render in headphones because we couldn't basically find a 5 or 7 channel system to set up. Now, if we have a really good 5 and 7 channel system at work, but it's not very portable. It's probably about 2 trucks worth, I think. And it's mostly a weight problem. It's not that big, but they're not light. So I will give this to Jim. And with that, I will also say, he's going to talk about this, not me, but when I put this, well, no, I'm going to do a couple more, Jim. But if we can do, the thing is, we can choose the environment. We have an environment designer. So if you want to do Carnegie Hall, we can do a really good fake of Carnegie Hall. If you want to do this room, we could do it. I'm not sure you want to do this room, this room, this room, this room. But you could do that. If you want to do the middle of a big sewer pipe, you can do that. It sounds terrible, but if you're talking about what does it sound like when you drive a motorcycle through a sewer pipe, you can find out. You can add more up and down cues. You can make the sound dominate. And you can, to some extent, fix what you recorded to make it sound more like the hall than the hall actually did. Many years ago, I did some stuff where I used a microarray to capture perceptual cues. It worked great. The problem was that it captured everything in the room, including the stuff you didn't want. Like, I didn't notice that air conditioner. Well, I do now. So the trip is sometimes you don't want some of the features of the room. One recording I made at one of the Smithsonian places had well, just say if you ever go to the gallery, the Smithsonian Gallery, it's right across from the White House, just walk into the main second floor room and clap your hands, and you'll find out why you don't want to use anything that comes from the upper part of that room. Now, point is, out of this, we can render it to pretty much any reasonable format. But this is the point I wanted to make. How do we do that? We let you enter the position. We let you design the space. And you can also move it around in real time. You can, on that screen right there, you can put your finger on a source and move it around. And you can move it around in real time. You can capture the path you took. You can edit the path you took. And all of that just works. And it runs fine on a laptop. And then, as I said, I was going to talk about subwoofers. Subwoofers were designed with a basic fallacy. Subwoofers, it is absolutely true that you cannot hear direction below about 90 hertz. However, you can hear spatial effects down to about 40 hertz. You can't tell where it comes from, but you can hear the difference between a wide room and a narrow room. And if you ever listen to some of these systems, even with 4 subwoofers that are very careful to be in phase and cancel all the room effects, you notice how they always sound squeezed in? That's because the signal is too coherent at the listening point. And a real space does not have that coherency. So if your mains make it to 40, you can do anything you want with the sub below that. But that's why I'm not a big fan of subwoofers, because I can make a really, really, really nice, very open recording, or playback really. It's not really a recording, it's simulated. And it sounds nice and wide when you use wide range speakers, and you put it into something that has a bass management, all of a sudden it gets squashed in. And that's the bass management. That's everything below 110, and it does that. So that's why I'm not a fan of subwoofers. Now, there are 2 more sets of tutorials. You don't have to read them now because there's at least 20 or 30 hours. But that will go up with the slide deck, and you're welcome to browse them. And now Jim gets to have fun.
And I'll take, as we grab the HDMI out of the laptop and plug it into mine, I will take this over to our computer so we can all see what's happening. But a couple of things just to kind of bring it down just one level. So the system is designed to give storytellers abilities that they've never had. So if I'm a storyteller and I want to hear somebody, the environment, the physical environment of the room changing as they cross the threshold into the room, system does that. If I want to put somebody in an artificial space, the system does that. But where it gets really interesting and where we've had a lot of success is to try to make a system that is dead simple to operate. One of the things I'm happy to announce today, and I'm going to start this with a quick survey, preferred video editing software formats, just quick show of hands. Premiere, Adobe Premiere, DaVinci Resolve. Notice the overlap. Final Cut. Yeah, we all, right? CapCatch, right? It's hard not to. What we've designed is a system that allows, what am I missing? Tell me what I'm missing. Blender. All good. Anybody else for Blender? Good. Any others that I'm missing? Where we see a sweet spot for this system, and where starting this fall we're going to be putting some more emphasis that I'm happy to announce here, is we see a sweet spot for this system in that Venn diagram of people who know video, who are required to produce audio, but hate spending time on audio. So what can I do that is dead simple for them that appears as another native element of whatever platform they're using, and that's where we're headed from here. So with that, I'm going to plug in the HDMI into Jan laptop and introduce you to the last few years of our R&D, which would be really good if it powers back up. We went to sleep during the presentation. You gotta love live demos. Here we are. Stand by. And we are live. I'm going to start showing you something first, just to give you a quick example of, so you can grok the visual elements of this. And then I'm going to actually bring somebody up here, a volunteer from the audience, to actually hear things. You win. So what you'll see without hearing audio at the moment is you'll see a bunch of dots traversing the screen as this file plays. And these are all recorded automations. So level, position in 3 dimensions, mute, all of those things, width of a stereo pair, these are all automatable elements. You don't have to do any of this stuff. You can quite literally take a 2-channel signal in, press make it a 7-channel signal, and it'll just do it. We don't care. But if you want to go and get really bespoke, you can design a custom environment to render the audio into. You can design custom layouts. You can go really deep with it. But at the core level, where we see this as being potentially the most powerful, is plug and play, click and go, spend no time on it. So with that, and now that the screen has died once again, hoping that this isn't what the rest of my night is going to be like, and believing that I still have power. Maybe I've just not been charging. Let's see. No, it looks like we have power. Ah, voilà. Merci beaucoup. And we are still looking for pop. We have, is that lit? Yeah, it's lit up. That's lit. There we go. Hey. Did it? It did? Ah, good. There we go. User error number 1. Don't forget to turn on the power strip before starting your demo. And momentarily, and user error number 2, the demo laptop woke up briefly. Standing by for technical interruption. Technical difficulties, please stand by. I have an interface that's powered up. That's promising.
Yeah, so that
Need some juice in the battery or something.
Yeah.
That went all the way down or something.
You must have. Promising. Ah, excellent. Good. Gotta love them. I'm going to just, for the good of the world, close this project and reopen it. Great. So, if you could, thanks, we are back now. And if we could, I'm going to hold the microphone so you can describe, in fact, even better than me holding the microphone in an intimidating manner. I'm going to bring this microphone stand over to you. Mount the microphone on the stand. This is what we get paid the big bucks for.
I feel like a lab rat. I don't know if that's going to mount.
And this is where I realized that the mic clip doesn't. It fits, but only at the end.
Testing, testing. All right, bring it over.
We are here, so you're seeing the interface on the screen. And why don't you tell us as this plays what you're experiencing, and you can all listen to this later. James. And here we go.
Out of my right ear, fizzing like a soda. It's just going up in hertz, getting quieter, more fizzing. Nothing.
The demo has stopped. I will play that loop for you one more time. So
Should I be moving my head?
you can move your head. So the headphones that he's using have a head tracking chip inside them. Otherwise, it's a standard Bayer T5P.
Wow, now it's surrounding my entire atmosphere here. Before it was just in the side.
Helped to turn the left channel on.
Did you have it off before?
Yes.
Well, it's only in the right ear. All right, that continued. That stopped.
So what we're able to do is deliver in this image, home plate with a pair of headphones depicts the listener position, and we're able to drive sounds around the listener, including behind them, with a standard pair of stereo headphones. Now, with the addition of head tracking, we deliver a more realistic experience to people, because even when you think you're holding your head still, you're making small movements and changing the way you perceive the sound field. The head tracking chip allows us to capture that, but table stakes for us as a company were that we needed something that would deliver the same user experience to somebody, whether they were using a pair of headphones that they got for free with their phone, or they had a $250,000 stereo system in their house that was properly tuned and set up for 7.4. The same experience, the same file, using whatever supply chain is in place. I'll mention on the side that JJ, being the inventor of the world's most popular audio codecs, we've identified in the supply chains that everybody is using, places where the audio codecs everybody uses today fall down. Not surprisingly, spatial content and spatial cues were routinely thrown out by codecs because at the time that these codecs were created in the early 1990s and before, going back as far as back in 77, 79, 82, thank you. Going that far back, we weren't thinking about preserving the spatial elements of sound. We were just thinking in terms of fidelity. But now,
there are two issues there. The first issue was that we didn't have enough memory in the computer to actually handle stereo. And the second issue was that all we had was pan-potted audio, and pan-potted audio is actually makes the coding easier. It just doesn't make it. It just makes it sound worse. But if anybody's using MP3, there's a joint stereo system. I will have you know that MPEG rejected the actual way to do it properly. They said it was too complicated. At the same time, they claimed that nobody would ever use layer 3 because it was obviously too complicated. That's what they told. That's what they said. So they published a standard and said nobody would ever use it. You gotta love these.
But this is the story of audio codecs, because a lot of these codecs were developed by committee with multiple rights holders, and everybody wanted the most lines of code and the most features so they could get the biggest participation in the patent pool. But the thing that nobody ever thought about was what's gonna make it sound best, which drove my esteemed colleague JJ bonkers. Should be about making things sound and feel better. So we fixed that. We have an entire family of codecs that are also part of our research expertise. What I've pulled up here, okay, James.
Use the mic. Use the force, Luke. The other thing I will say about the competitions in MPEG, the competitions in MPEG were very carefully designed by some of the rights holders to make sure that it got the right answer. More than that, I'm not going to say unless you get me a beer.
I'll buy you a beer.
Which will be available after this. Yeah, so with that, so what I've now done is I pulled up a multi-track session that's actually running in 3 dimensions. So this is a project from an artist called Juanis, a great mixer called Sebastian Chris, 20-time Grammy winner, does lots of work with Latin artists, but also does, has multiple Grammys with Elvis Costello and other artists as well. So the great thing about getting a mix from Sebastian is I know that I can take all of his stems, put everything at one level, and get exactly his mix back. This workflow, which we automated into a 3-dimensional model, took us in its entirety maybe an hour on a Sunday afternoon, and it just kind of pulls together because there are other things that you can do in the immersive space in audio. You can deconflict things. You have 2 speakers with similar tonality in their voice. You can separate them by the tiniest little bit, and all of a sudden they're more articulate. You have conflict between low-frequency information and low-frequency sources. You can literally array them front to back, and all of a sudden the conflicts are resolved. So with that, why don't you tell us what you're experiencing as you hear this, and then, of course, we're happy to share these with you after. And this is where I realize I've got you set up at the beginning of the song, so I'm going to, for the sake of time, park you a little farther up. And the track, here we go.
All right. I can't even speak because it's so awesome in here. Going around. You said these were stereo headphones?
There are only 2 drivers, a left and a right.
A lot of headroom, a lot of swirling, but only of the right tracks, isolated tracks. I'm only yelling because it's really awesome in here. You know how your mom said, stop and take your headphones off.
This is the closed caption version of the demo. So we look forward to sharing all of this with all of you. The best part, I'm going to leave you with this platform with 1 bit because I know we have another speaker coming up, and we really appreciate the invitation to show you what we're working on here. When I press export wave, it asks me which format I want. I do not have to touch anything. I don't need to go back and do a separate mix for Atmos. I don't need to do a separate 5-channel mix. I don't need to do a separate stereo mix. Everything's available, and it just renders it as a different package. And if you're running this in the cloud, and we have a version of it running on a commercial cloud right now, it will render all the outputs simultaneously. Delay, people ask me, what's the delay time? Generally, if we are taking somebody's content in and rendering it back out live, it's far within the broadcast profanity delay, generally south of 500 milliseconds. And if we are just doing dialogue enhancement, it's real time. We want maybe 50 samples. So that's a quick walkthrough. Thanks for having us. How about questions, thoughts, comments? What works, what doesn't work? And I will hand the microphone over.
You guys have a mic up here still?
Yep.
I think first question is, when I move my head to the right, to the left, it automatically panned to that, the sound, which in this channel, when I moved over here, is there something going on with that, with the movement of the head?
That pair of, so think about what's really happening, right? Just everything that we do in our stock and trade is about reproducing human hearing perception through the code that's running on this. So that headphone is listening to a virtualized 7-speaker setup, or 7.4. It is 7.4, that's right. A virtualized 7.4 head, and just as when you turn your head, you would be hearing balance more out of one speaker than another. It's happening in the headphones as well.
I should add a little bit to that. If you think about it, tracking your head is identical to rotating the rest of the sources. So we don't care. You can move the sources. You can move your head. You can move both of them. It's just you're in a free field, basically. You can move, or not an acoustic free field, but in a free space. You can move it any way you want.
And similarly, yes. Yeah, so that, and similarly, we can take any of the tracks, any of the audio elements can be assigned an X, Y, Z axis from like Unreal 5, and we'll take those inputs live. You can deliver an X, Y, Z to us, the thing mixes itself, it positions everything by itself.
So your presentation was a lot about like how us humans like perceive and understand audio, but something we're dealing with in our industry right now is computers listening to audio. Like for example, if we want to like auto-generate captions from like like the audio that's available on a feed. Like if a truck is driving by, like our generative AI shit like goes like, oh, I can't understand what the fuck is going on anymore because like there's a truck going by. Is that something you guys are like looking into and making better?
We have active live stuff working we have active live research working on it right now. It is basically the same thing you heard on the Bluetooth speaker. What we found is that, again, emphasize the formants, preserve those, protect those, and funny enough, the captioning software becomes considerably more accurate.
I could add something to that from long ago when I was still at Bell Labs. If you really want to do something, you should try using the actual partial loudnesses into your speech understanding thing. I can't go into more detail, but that is a really advantageous thing. It gives you a lot of scale, and it gets rid of a lot of scale dependence.
Next question, yes.
So thinking about the latest headphones that have head trackers, specifically going back to the last question about the head tracking, what's your input for the head transform function, and how are you tracking the head exactly?
So
are you using earbuds or using?
I'm so glad you asked that.
I'm just curious.
I'm really glad you asked that question because HRTF, here, let me put this online. Yes, we use an HRTF, but we find that personalized HRTFs are bullshit.
What I would say is that if you give the person to move their head around in the space, they learn what you've got, what the HRTF is. If you think about it, if you take your hat off, you change your HRTF. You adapt very quickly and very easily to anything that's a plausible HRTF. So that way we don't have to do personalized HRTFs.
And incidentally, we found that when we looked at a lot of the data sets that people were using for the better known HRTFs, they contained mathematical errors, and they were not subtle.
Data errors, impossibilities. There was all sorts. We went through a whole bunch of the basic data sets, and it was pretty obvious that people didn't run a good, very much of a good consistency check on it. Well, no.
All right, let's take this conversation to the mingling part because we got to get to our next group.
Okay.
Thank you very much.
It was a round of applause for quite a storied career from JJ and Jim here. So, you know, if you don't know who JJ is,